All right, welcome back to Computer Science E75. So we rearranged the schedule a little bit. So tonight is actually security, but still on the horizon are scalability and user interfaces. So tonight will hopefully be particularly useful as you start to think about final projects and such, and actually start to sketch out designs for them, since the proposal for the final project, recall, is due next Monday. So do review the spec, which has been online for many weeks, on the projects page of the course's website, just to see what's expected there. Essentially, the process involves proposing an idea that's of interest to you. We then offer you a sounding board in the form of this is perfect, this is a little too light, this is a little too much, and we'll try to help guide you toward what we suspect is realistic, given what we've covered in the course and how much time there actually is. Generally, what we urge students to do is consider sort of a good plan, whereby if they implement this set of features, they will think of this as a good project, something they're happy with, then a better sort of milestone, and then a best milestone. Because realistically, what tends to happen is you shoot for best, but inevitably things take way longer than you actually imagine. And what we want to make sure is that what you ultimately submit is in fact something you're happy with and actually functions, even if it's not as feature-rich as you might aspire to implement. There's always time after the course if you really want to take it further. So with that said, too, you'll be able to host your projects on the cloud server, as you've been doing for these various projects, but certainly realize if this is something you want to continue after the course, toward the very end of the semester, we'll let you know via email or in class how you can transition yourself off of our servers and to some commercial web host if you want your project to live on at your same domain name. Though presumably if you have it living at projects.something.com, that's probably not going to be your startup's name, so you can certainly change the URL as well. So today is ultimately about security, and it was kind of apropos that I just read like today or yesterday? Yeah, today. This post on Slashdot, the Royal Navy website is hacked, passwords revealed. This goes on to say, the British Royal Navy's website has been suspended after a Romanian hacker exploited SQL injection vulnerabilities to gain access to the site. The hacker, named Tincode, accessed usernames and passwords used by the site's admins and published them on the web. ... So the sad thing is, as you may have realized just from writing your own code, this is such an easy attack to prevent. We'll take a look at a concrete example tonight, but every time you've sort of grimaced at writing out that stupidly named function, MySQL real escape string, it's actually a wonderfully good habit to get into, because it really is as simple as using a function like that, whether in PHP or any other, to ward off this attack. So this almost always boils down to oversight, to stupidity, to lack of awareness of what these attacks actually are. And so what really tonight is about is familiarizing you not only with this attack, which we've talked about a couple times already, but any number of others, and thankfully many of them are relatively easy to defend against. You just read so many of these articles, presumably because people just don't remain mindful of these issues, or just never realized how vulnerable their work actually is. So there's some obvious threats when it comes to security when you're implementing a web-based or some other type of internet-based project. And some of these are perhaps obvious. So if unfamiliar, Telnet is sort of an ancestor of SSH, whereas SSH is secure shell. Telnet still allowed you to connect from your computer at a command line to another computer remotely, but everything was in the clear. Your username, your password. And this might seem rather horrific these days in that almost every account you probably have is used as encryption. But as recently as 10, 15 years ago, even on this campus, there were thousands of FAS users who were telnetting to their FAS email accounts with their usernames and passwords just going off in the clear all day long. Now, in fairness, back then, most everything traveled across a wire, so it was a lot harder to intercept that traffic unless you had physical access to the medium. But back in even my undergraduate days, a lot of the undergraduate houses had wired Ethernet, which feels like a good thing, but they had hubs instead of switches in the basement of the various buildings. And for those unfamiliar, a hub is pretty much a stupid device with a lot of Ethernet ports. Stupid in the sense that when some data comes in on one cable, it just broadcasts it out to every other Ethernet cable plugged into it. And then by design, computers that support Ethernet are only supposed to listen to those packets that are actually addressed to them, even though they will hear everyone else's packets in the nearby vicinity. So it was not uncommon for the more savvy computer science types back in my college days to probably be being a little nosy when it came to emails going around the dorm or the equivalent of instant messages. It was relatively simple if you knew what to do. You put your Ethernet card into what's called promiscuous mode. Thankfully, it's pretty easy to avoid those kinds of attacks these days by not using Telnet at all. So if you're ever on a system, frankly, that's using Telnet, you should definitely raise an eyebrow. And if you're using it over the internet, definitely a bad idea. It is still used, though, on equipment sometimes. Some Cisco hardware, for instance, switches and routers, will very often support Telnet, but the idea is that you're only supposed to connect to those pieces of hardware via direct cable or via a very local area network that you control, so that it's going across in the clear, but there's no one there to listen to it. So it's still perhaps used, though not the best system, certainly. So FTP, File Transfer Protocol, is actually very much still in vogue, not even for better or for worse, for worse. You have many commercial web hosting accounts out there that you can pay 5, 10, 20, whatever bucks per month for, and they give you FTP access, which is great because then you don't have to use some annoying, poorly designed web interface. You can actually upload your files in a manner that's a little more efficient, with which geeks tend to be more comfortable, but it's incredibly insecure. Just like Telnet, usernames and passwords go completely over the clear. Now, 9 times out of 10, probably no one cares that you're sending a username and password over the internet, but if that same username and password is used to access your billing information, to change files on the server, to access your intellectual property, you're literally just shouting it out on the internet, just hoping that no one will actually be listening. And so this, too, is a protocol to be avoided. And in the context of this course, if you do shop around for a commercial web host, beware any service that's still providing this. It is so relatively easy for them not to these days that you're really better off spending $5 more and turning to someone else. This is kind of a deal breaker, I would say, these days. And yet, a lot of the population doesn't necessarily realize that. And an FTP sounds great. I can access my files, but not so. HTTP. So this one we'll talk about in greater detail tonight, especially in the context of a tool that's been making its way around the internet since 2 weeks ago. In fact, I literally got an email 2 lectures ago that I think I read shortly after the break about this new tool that had been released that day called Firesheep. Well, I've since played with it, as have unfortunately millions of people on the internet most likely, and it's shockingly easy to use. And I'll give you some screenshots tonight, and we'll discuss exactly how it works. And in fact, even though we talked about this briefly in weeks past, the idea of a session hijacking attack, I mean, literally 2 lectures ago, that day, did these attacks become ever more real and ever more easy to wage, such that any kid on the internet can now download this tool and log into your Facebook account, various Google accounts, your Twitter account, any number of accounts that are popular today. It's frighteningly easy, and it's going to take the world, presumably, some time to fix this properly. So we'll also talk about some defenses tonight that you can use in the meantime. So MySQL. One of the things you might have learned the hard way when working on your projects on your local laptop or desktop is that you cannot connect to your MySQL account on cloud.cs75.net. The reason being, we packet filter, and we don't allow any MySQL traffic from the internet coming into the servers, essentially because it's completely unencrypted, specifically the login mechanism, your username and your password. So if we were to allow you to call MySQL Connect with your host name, your username and password, and you connect it to the cloud from your local machine, you there too would be shouting your username and password across the internet, which is not ideal. So this is pretty standard practice, really in any topology, to hide your database server behind other layers, much like we've done here. A little annoying in that you can't develop remotely but still connect to some central database. There are workarounds. You can use SSH, in fact, for many purposes besides just command line environments. Very common is to use SSH. To create what's called a tunnel, whereby you can essentially create a virtual private network between your laptop or desktop and most any remote server. And even though SSH itself tends to use port 22 as the standard TCP port for internet traffic, you can configure your computer to then send all TCP port 3306, which is MySQL by convention, through that SSH tunnel, where it then connects on the other end to the actual MySQL database. It's a little more involved. We tend not to do this in this course because it just involves too much complexity on both ends, but it's not terribly hard to do, and it's common practice if you want to encrypt anything between point A and point B. So realize there are workarounds, but built into PHP's MySQL library, and MySQL itself is not sort of off-the-shelf, easy-to-use encryption. The passwords by default are sent in the clear. So that's one matter of concern. Any questions about some of these more obvious threats, even if some of these protocols were until now unfamiliar?
Is FTPS better better than FTP? I mean, is FTPS okay to use?
So, by the way, SFTP. So SFTP, Secure File Transfer Protocol, is wonderful. It is essentially FTP over SSH, though there's some slight differences, but it is a secure form of FTP. So if you're offered that in a server or in a web hosting company, that's good. SSH, SFTP are good. FTP bad. Telnet ridiculously bad. Other questions? And now that you've prompted me with that question, let me remember a promise that I made right before we began, which was just to mention quickly how you can save yourself some steps in terms of validating your code. So as we've said in the past, there's a number of wonderfully useful free tools for Firefox in particular, but other browsers increasingly have these kinds of tools built in, and that's namely something called Web Developer Toolbar. So if you install this thing, and it's on the software page on the course's website, you'll get some additional menus: disable, cookies, CSS, forms, images, information, other tools, resize. To be honest, at least in my sort of daily life, I find the resize tool invaluable, at least when I'm coding on a desktop computer with like a 24 or 30-inch monitor, which is way bigger than most people's screens, which is bad because you can very quickly start developing really nice interfaces that are way too big to fit on a normal person's screen. So I will very often develop using Firefox and then click resize and then choose from this dropdown after I've configured it, say 1024 by 768, and my window will immediately shrink to be those dimensions. This projector only supports 1024 by 768, so nothing happened. I can downsize it to 8 by 6, which is kind of out of vogue these days, and you're probably safe just cutting the cord on people whose resolutions are still this low, but that's what it does, and it's a wonderfully useful development tool for that purpose. So you're not overestimating, but germane to validation is this. If you visit some web page, especially CS75 Finance, or any page you've designed that's behind some kind of login mechanism, you of course can't just copy the URL, go to validator.w3.org and paste it in, because when they try to validate some specific page, your buy page or your sell page, of course they, like you, are going to get redirected to the login page. So that is to say that the W3C can only validate your login page, it would seem. So you can, of course, visit your buy page or your sell page and view your source, copy it, and then paste it into validator.w3.org. by clicking direct input, and you get a big text area that you can paste into. But this very quickly gets annoying. It's just too many steps to be all that much fun. And so you can, with Web Developer Toolbar, go to Tools, validate local HTML, and this will upload the source code of the current page to the W3C site and essentially automate all of those steps for you. And I'm actually spontaneously curious to actually run the validator on the validator in sort of a very meta approach here and see what happens. Very nice. So the validator is in fact valid. Otherwise, that would be a bit of hypocrisy there. Though with that said, there are probably E75 pages that over time have gotten a little messy, so we should fix those too. Anyhow, back to security. So the biggest one we discussed very early on in the semester was this potential threat of being on a shared web host, which the cloud effectively is. We have hundreds of students on this server, and it would be a bad thing if all of you were working on your code and you wanted to keep it private, whether it's your final projects or assigned projects, and yet if you had to chmod your code 644, that is, make it world readable so that the web server can actually read it, that would be a bad thing. The web server on a typical Linux system or even Windows system runs under a certain username, whether it's administrator or root, which tend to be bad, nobody, web, Apache. There's so many different monikers under which the web server software runs. But the point is, it pretty much runs as anyone other than you. And that's the catch, because if you want your code to be private, it needs to be viewable, it needs to be readable by the web server. Unfortunately, Linux permissions and Windows permissions are often not terribly fine-grained, at least for shared web environments. And so you can pretty much say everyone can read this, or only I can read this. In the former case, at least the web server can read it, but so can everyone else. And so you run into this issue of, well, let me at least... let's say, and there's this other gotcha. So suppose the web server is in fact running under some other user ID, say it's nobody or Apache, and you're comfortable, you accept the fact that you have to chmod it so that it's readable. Unfortunately, what happens if your site takes input from users in the form of file uploads? Well, if they're allowed to upload files, maybe photos, if it's a photo website, those files, when saved to disk, are not going to be owned by you, they're going to be owned by nobody, whoever is actually running the web server. So then you have this other concern whereby I now need to make these photos when they're uploaded world readable, which might completely defeat the purpose of having user accounts or anything like that. So long story short, it gets very messy quickly if the web server is not actually running as you. So one alternative is don't use a shared web host. Run your own server, and then you can do whatever the heck you want because it doesn't matter if everything's chmodded 644. If you're the only one with access, not as big a deal. That's probably not feasible for a lot of people, whether for technical reasons, financial reasons, or just logistical. That's a pain in the neck. Why do I want to take on responsibility for managing a whole server when all I care about is solving this one problem? So thankfully, there exist tools like SUPHP or Fast CGI is another one. The course happens to use SUPHP, and does anyone recall what this does for us or what the acronym stands for? Technically, substitute user, PHP. And as that suggests, it means don't run my PHP code as me, run it as some other user. Substitute the user running this code with my own username. And so what SUPHP does is it looks at the username that owns a particular .php file. And if it's Malin, what happens is the web server takes on my identity temporarily and runs that code as Malin, does its thing, and then it does the same thing for all of you using your own username for any PHP files you've run. And so this is sort of the best of both worlds, where now I can really have my permissions nice and tight on the web server. I still don't have to give up any flexibility. I can still allow file uploads and the like. No one else on the system can actually see my files, and yet I can still use something like PHP. So there is a downside. What tends to be the downside almost any time we introduce a solution to something in the form of some new software? What could be a problem or downside? Yeah?
Well, I know that when I've been developing for this course, I've had a hard time with version management control.
Okay.
I have to store things so that they can be readable on my own system, and I know that if I chmod things 600, they're not readable on my own system.
Oh, interesting. Okay.
So, because version control systems don't usually store permission, it's made it difficult for me to synchronize my development environment with the cloud.
Well, that's a good point, actually. I should ponder how we can help fix that, to be honest. But that's a good point. So that's one downside that I didn't even really appreciate, since I tend not to do my own development client side. Other downsides? Almost nothing in technology life is free. What do you usually spend to get some new feature? Oh, so performance and, sorry? Administration details. So there is that issue. Frankly, I was getting a little ticked off at SUPHP trying to get it to work on Fedora for the first time, just because every damn Linux distribution does things a little differently. And this was not all that much fun a thing to have to do at the beginning of the semester, is figure out yet another version. So that's certainly compelling. There's some additional complexity, yet another tool that might take time, might be buggy itself. And then another is performance. So in fact, there is a slight performance hit you take when actually using something like SUPHP because of the intermediate step that needs to be taken, changing mode essentially to your username, executing the code, and then proceeding to do the same kind of thing for most everyone else. Thankfully, there's kind of a built-in solution here. If your website is so popular that you're really starting to push the limit of your 1 or 2 or 3 gigahertz CPU such that the performance you're spending on this is probably an issue, at that point, you're probably better off transitioning away from a shared hosting environment and something that's more dedicated to you. So what's at least nice there is that that's probably a good problem to have. If your site's doing well, you can then at least consider taking even more control over the server. But that too comes with a cost. Then you have to manage your own server potentially. But thankfully, there exist things like these VPSs, virtual private servers, that we discussed very early in the term, which is effectively what the cloud is as you would perceive it as a customer. Actually, no. Let me retract that. Ours is a shared web hosting environment, but we ourselves certainly run VMs that have dedicated services. For instance, in the course, we have a dedicated file server, we have a dedicated LDAP server, and these are controlled only by us, but they're VMs, not actually machines. So that's SUPHP, and there exist counterparts in other languages. So here's the fun one, and out of curiosity, Besides lecture 2 weeks ago when I mentioned it by reading the article off my phone, how many of you have heard or seen or played with Firesheep since? It's okay, you're off camera if you have actually played with it. Okay, so a handful of folks in this room. And has anyone not heard of it or not heard anything since 2 weeks ago? I didn't phrase that perfectly clearly. But let's assume that most everyone's familiar, but we'll do a quick recap of what it is, because frankly, it's at least as sufficiently real a threat that even I, earlier today, just sitting in a restaurant doing some work and eating, even I thought twice about, wait a minute, should I really log into this site here if I'm on some free Wi-Fi? Probably not the best idea, knowing just how many, curious technical people live in this area, whereas I'd probably be a little more loose if I were in the middle of the suburbs where people are not probably threatening my own privacy. But even then, the threat still exists. So why does this threat exist? Well, we've talked in the past about, in PHP, a superglobal called $_session. And it's in $_session that you get the illusion of state management with the user. You can put anything you want in that superglobal, key value pairs, and you can pretty much trust that the next time that user visits one of your web pages, so long as you've called the session start function, you will be handed back that same copy of the session superglobal. And you effectively get the illusion of one such session superglobal for every one of your users. It's not shared across all of your users. Each person gets their own copy, their own version of it. How is that done? Well, recall that it's cookies to which this technology owes its implementation. So here is a snippet of an HTTP response from a server to a browser. I say response because you can see in the top line there that it says 200. Okay, 200 is a good status code to see. We then have some lines here, some of which are arguably some security threats, but we'll come back to those. But down here in bold is the ones that are germane right now. Set cookie, PHP sesh ID, and then some really long, presumably random number, and then another one below it, which is even worse, secret equals 12345. So we proposed a while back that storing users' usernames and passwords and cookies, kind of a dumb idea, because of course it gets stored locally on their hard drive. If it's a lab computer, that's definitely not good. Even if it's their own computer, not the best thing to have any form of sensitive information stored in clear text, not actually encrypted. So this bottom row, set cookie, might be what happens if, in fact, you make this mistake of storing something sensitive inside of a cookie. So even if you don't do that, this guy is very much in play anytime you're using sessions in PHP. And there are similarly named cookies that other language environments use to create this same illusion of state management over HTTP. How is this big random number used exactly? Anyone recall?
Is it the key in a user hash table?
Yeah, it's essentially a key in a user hash table, and it's a pretty simple hash table. It's just /temp, which is a temporary folder on most Linux systems. In that temp folder, recall, are a whole bunch of text files, and each of those text files is named usually something like SESS _ big random number, and that's the file that's storing the contents on disk of Joe user's session superglobal. And there's another such file for Jill, and there's another such file for Alice and Bob and Charlie and so forth. Every one of us, if we're visiting a website, has our own file inside of /temp. Now, as an aside, those files are sometimes stored in an actual database because we run into issues of session stickiness, which we'll talk about in a week or two in the context of scalability. But for performance, for scalability, they can be stored in a MySQL database or the like, but that's not a solution to the problem at hand. What is that problem? Well, the way that a website remembers that I've been logged in already and I should therefore be shown my account balance or my Facebook wall or whatever it is I'm seeing on this website is because, unbeknownst to me, the user, once I'm logged in, my computer, or rather the server, remembers that I'm logged in by planting this big random number somewhere on my hard drive or somewhere in RAM. And according to the HTTP standard, anytime my web page visits another page within that same domain usually, it is supposed to send, behind the scenes, cookie colon, and then that same big random number. So the server sends set cookie. The browser is supposed to just say cookie colon, big random number. And if you've ever been to like a club or an amusement park where they stamp your hand, if you temporarily leave and go out into the parking lot or the like, they stamp your hand so that you can come back in without having to repay or whatever. It's very similar in spirit. When the web server wants to remember you, it stamps your hand with a big random number, and then unbeknownst to us, the humans, the browser is supposed to constantly extend its stamped hand every time it talks to the server thereafter. So the danger here is, what if someone else kind of does this trick at the amusement park, makes a copy of that stamp, and then presents that same stamp as though they were you? It boils down to the server probably trusting that that hand stamp is sufficient to let me back into the club or let me back into the amusement park. So this term called session hijacking refers to exactly that, sniffing around on the wireless network or sniffing around in someone's history or something like that, generally stealing someone's session ID and then presenting it to some web server as though it actually belonged to me. And unfortunately, the way sessions are generally implemented, they don't check my IP address to confirm that it came from the same source. They simply trust that if you have this big random number, the odds that someone else on the internet is going to choose such a big random number that's identical to yours is just so small, we're just going to accept that this is very unlikely to happen. And in fact, if it does happen, it's just going to be incredibly rare. This is, in fact, a pretty long number. And in fact, even if you did verify against IP address, that feels like it would be a solution to this, right? If the problem is someone else is claiming to be me with the big random number, let me just filter out every IP address except the original one. What's the danger there?
It's not going to work because somebody's using a router, probably NAT.
Exactly. Exactly. If you're in your home network, you are sharing generally one IP address to their home router. Maybe you can mostly trust your family. But if you're sitting in Starbucks, they too probably use NAT so that they're on a private network. They only own one IP for that particular coffee shop. So you're going to both appear to be coming from the same network, so the server's not even going to be able to distinguish you anyway. So in short, the current system works. It's not great, but it's hard to make better with some of the obvious instinctive approaches like just checking for IP address. So what does this tool called Firesheep do? Well, the context here is that about 2 weeks ago, there was a fellow by the name of Eric Butler, who put together a presentation at a hacker conference, and I think the title was in fact this: Hey Web 2.0, stop protecting user privacy instead of pretending to. And essentially he threw down a gauntlet, frankly, to the whole world. Supposedly he didn't quite realize that this was going to garner as much international attention as it did. But what's fascinating about the story we're about to tell is that this threat, I mean, it certainly existed 2 weeks and a day ago. We talked about it earlier in the semester. It's existed for 10 years, this ability to steal someone's session. But what this fellow did is lowered the bar so amazingly low such that anyone can now do it with just two single clicks. And so what his motivation reportedly was to really actually kick the world in the backside to actually spur people on solving this problem properly. And to be honest, given that the world has had 10 years to do so, I actually think, even though there's definitely some downsides of this, probably wasn't in the net such a bad thing. So that you're actually getting the authoritative information, there's a lot of stuff you'll find if you Google around. This is the fellow's blog, if you go here, and you can read about his original post where he talked about the presentation he gave, and I think he has his slides from the presentation, and it's actually fascinating stuff to read through. And I'll post my own slides after tonight if you don't have time to write this down. And then a day later, after the tool had been downloaded some 100,000 times, he posted a follow-up to his blog discussing some of the sort of takeaways of that brief experience, and it really did garner international attention. If you start Googling Firesheep now, you will see a ridiculous amount of coverage in the press, for the better, to be honest, because it really did educate a number of people. In fact, one of the most, I think the program's name was Idiocy, something playful like that. But 1 or more days after this tool came out, someone wrote their own Firefox plugin that I believe, if I'm remembering the story correctly, used the tool that you're about to see screenshots of to log into people's Twitter's accounts, post a tweet to their own account educating them on how they've just been compromised and how to avoid it in the future, and then closes the connection. So kind of, a little playful there, but probably for the better. So there were a number of side effects of what happened here. So this is what the tool actually looks like. So this is a screenshot of Firefox, and embedded on the left-hand side is just a Firefox plugin, free download. You can download it if you'd really like, and you literally click Start Capturing. And if you're on a wireless connection, and you've run the program essentially with an administrator account, it will start listening to all of the wireless traffic in the vicinity, and it will look for URLs from known websites, among them Facebook, Google, Twitter, and a bunch of other websites. Not all of them, but many very popular websites that are of interest for a tool like this. And what you then see is a list of all of the usernames and the sites of people in the vicinity who have just logged into their Flickr account, their Twitter account, the Google account. And here's the bar lowering part. Now, if I want to log into Ian's account or Eric's account, click, click, done. And what you would then see in the right-hand side, which is just a browser window, is the Facebook wall of Ian or the Twitter account of so-and-so. You would be automatically logged in, and as this screenshot suggests, it literally is that easy. So what is the tool really doing? Sniffing all this traffic. It's looking for the host field for popular websites. It's then looking at the cookie : HTTP header. It's making a copy of that big random number, remembering it in some kind of an array. And then when I, the user of this tool, am ready to double-click on someone, it then sends itself an HTTP request, sends that cookie header, and then voila, I'm logged in to that person's account. So it is terribly, terribly easy. And the other day we did an example in another class of mine where there's decent wireless in the vicinity, there's many more students, and we saw literally over the course of 5 minutes before lecture starting, we had some 30 accounts that literally could be compromised by just double-clicking on the student's name. So it is that easy. And I'm sure if you walk into Starbucks these days, or any of these free Boston wireless setups or Cambridge wireless setups, I mean, there are now people doing this to you. So if you take nothing else away from tonight, do realize that this is absolutely a threat that you should be mindful of now, because it's so damn easy for people to start poking around. But in a moment, we'll talk about how to defend against.
But this is only a threat for sites that don't encrypt the connection. So anything you attach to HTTPS, are you safe?
It's a good question. So, short answer, it depends. As we've discussed, many, many websites do use HTTPS, but only for logins. For instance, Facebook does. I mean, any website out there today, frankly, does that. Uses HTTPS for logins, but then bounces you back to HTTP for most every other web page, except for bank websites, except for Gmail, which only recently, a few months ago, made this change. And so you are safe from this particular attack. Let's just take this off the table. You're safe from this particular attack for any website that uses HTTPS for everything. You are not safe from this attack if the website tries to use HTTPS for everything, but still supports HTTP and does not have their session cookies flagged as quote-unquote secure. So many of us are probably in the habit of clicking on your address bar and just typing in something like facebook.com, enter, and we let our browser do the autocomplete of http:// at the beginning and a slash on the end. Now, most browsers, by convention, assume that you want HTTP just because that's the common case. So unfortunately, if you've been to Facebook before and you've logged in before and you therefore have a session cookie, but you, the human, just out of laziness or naivete, just type facebook.com, which your browser then translates to http:// facebook.com. It's very possible that your browser will then make a request to http:// facebook.com, will send that session cookie, and voila, you've now been compromised, because your session cookie, even if it was given to you over HTTPS when you first logged in, your browser just very naively sent it over in the clear. Because many websites, even if they don't use HTTPS for everything, do not flag their session cookies, like PHP sesh ID, as quote-unquote secure. One of the options in php.ini and other languages configuration files is to say, do you want your session cookies to be secure or not? This literally just adds a keyword to the HTTP header that says secure. If you turn this on, that tells the browser that it should only send this cookie across the internet if the connection is over HTTPS. But the gotcha is that there are numerable websites out there that think they're doing best practice by using SSL for their login pages, but are not flagging their cookies as secure. And so as a result, by way of a very common behavior pattern on our part, just typing in a short URL, a short domain name, and not the full URL, we ourselves might be divulging that session cookie, even if it's just for one request. And so you're vulnerable there too. So a danger, indeed. And this is true even, I think, of some bank websites, whereby they do operate over all HTTPS, but they still support HTTP because they don't want people to reach a dead end if they try visiting HTTP. But again, if their cookies are not flagged as secure, you could divulge your session cookie even for something like a bank. So you have to beware even contexts like that. Another question.
It seems funny that there's not another way to generate a random number that involves some kind of chaos on the client's machine that would let you identify them. That would change, but in a way that would be predictable for you somehow. Is there no other way that you can verify identity without SSH or without HTTPS?
Good question. So to recap for the camera, is there no other way you can essentially authenticate the user? You generally need some form of cryptography, whether it's for encryption purposes or for signature purposes, digital signatures, which allow you to verify your identity. The gotcha is, though, that there's other problems involved there. We do have things like SSL, which frankly is going to be one of the best solutions to this problem, as we'll discuss in a moment. But the problem there, too, is that SSL technically has vulnerabilities. It is imperfect for a number of reasons, even though it's still better than nothing. And so we just create new problems for us there. But in short, the simplest solution to this problem is indeed cryptography, but implementing it correctly. And the fact that many session cookies are not flagged as secure is a wonderful example of sort of good intentions, but not fully understanding how all this stuff works from the ground up, which frankly is one of the themes of this course, not just talking about how you write PHP, but how it's really being implemented under the hood so we understand these issues. So in short, crypto does help us here, and we'll see in just a moment. So what then are some solutions? Well, what about cryptography on the wireless network? So one of the interesting things that's happened over the past few years is you try to steal someone's Wi-Fi, and it's getting much, much harder because almost everyone now is buying routers that encrypt it by default, home wireless routers and the like, or they're consciously turning on encryption. Unfortunately, many of them are still using WEP, wired equivalent privacy, which sucks. It is imperfect, it's flawed, it's very easy to crack, even if you have a decent password. So thankfully, there's WPA or WPA2. WPA2 is not bad so long as you have a reasonably long passphrase. If you're using 1, 2, 3, 4, 5, it too is quite vulnerable. But at least with WPA2, you do get encryption between you and the nearby wireless access point. Now, what's the implication of this? That's a good thing, because at least now if the data between me and that wireless access point is encrypted, now it's not as bad if I'm just sending these cookies over the internet, or rather over the wireless network in the clear, because now only I and that access point can decrypt them. And WPA2 should isolate pairwise users and that access point. So even people who are also connected should not, in theory, be able to see that traffic. But this doesn't fundamentally solve the problem, because plugged into that wireless access point is probably an Ethernet cable that's connected to some router. The rest of the story goes out in the clear over the internet. And so in theory, if you have a more sophisticated adversary with like a landline connection to these internet services, or if you have some malicious employee at one of these network operations center who is just watching and sniffing all of these people's traffic, absolutely could your session be hijacked. But the reality is, at least for the stuff that's been going on in recent weeks with Facebook and Twitter and the like, it's mostly the nearby people, the curious people, the malicious local people who just downloaded some free tool that you really need to worry about. At least once your data gets a couple routers away from you, you're still vulnerable, but odds are you don't know anyone or no one cares that far away from you about you specifically. You would really just be one of many people's accounts that they might compromise for spam purposes or the like. Yeah?
Can you just say that again about you're in the coffee shop and if they are using WPA encryption, you're okay or you're not?
Good question. If you're in a coffee shop using WPA2 encryption, you are more okay, if I can say. The catch is, I don't think I've been to one coffee shop in like 5 years that's actually used encryption. And even then it was WEP. Most coffee shops, most campuses, even a lot of corporate networks don't necessarily use encrypted wireless because of the logistical challenges involved in actually configuring everyone's computer with the key phrase. So in fact, like Starbucks, the Harvard Square free Wi-Fi, Logan Wi-Fi, I mean, anytime you have public internet access, even if it's restricted, whereby you need to pay $9.95 with your credit card or anything like that, it's still unencrypted for ease of maintenance, ease of administration, essentially. Even Harvard is completely unencrypted. So what then are the implications? It's simply not available. It's not available a lot of the time, and it's not available in a lot of the most vulnerable circumstances, like the coffee shop, like the airport, like the hotel, and the like. So is there a solution when you yourself don't control the network infrastructure, which is very commonly the case unless you're actually at home? Well, turns out with some sites, you can just add the S yourself. Many of these websites that are common today do support SSL, but thanks to Apache and mod rewrite, or the equivalent, they try to bounce you off of the HTTPS pages as quickly as possible, generally because some more CPU cycles are involved in encrypting a connection than in not encrypting it. Now, with that said, one of the studies or blog posts that came to greater light after Firesheep is one by Google. When Google switched Gmail to all SSL, they claim in a public discussion thereof that they did not have to buy more servers for that particular change, and they supposedly only had a 3% CPU increase, but presumably thanks to some cleverness or some configuration on their part that might exceed the savvy of a typical user who really just knows how to like check a box or change a configuration file to turn it on or off. So realistically, it does generally involve a bit more computation, but it's been offered to the community that this is not a deal breaker and that this claim that you need more money, more hardware is not necessarily the case if you solve the problem rather cleverly or if you fine-tune your setup. But even so, there's a gotcha even with a site like Facebook. Facebook supports SSL for all of its pages, but what was the context here? But the irony is, you can change your URL to HTTPS with Facebook, and from there, they pretty much use all relative URLs. So when you click around, almost all of your traffic will stay on SSL. But the gotcha is when you do log in, they force you to HTTP after you've logged in. So ironically, right after you've logged in is literally when they disclose to the world what your session cookie is. And someone like Facebook, in fairness, it's a little non-trivial for them to just change to SSL overnight. One, because they have a heck of a lot of servers, and thinking this through in terms of performance probably is non-trivial. They also have a ridiculous number of third-party integration these days, which relies on HTTP. So if they suddenly switch to, say, secure cookies and to HTTPS, could very well be that a lot of their efforts to proliferate on the internet with these third-party plugins on CNN.com and the like suddenly stop working, at least for some people, if now it requires HTTPS changes there too. So they in particular are kind of in a bit of a headache situation that they didn't do this from the get-go, but now presumably are seeing accounts hacked every day, which is not fun. I'm sure it's happening even on campus here. So what are some better options than yourself just manually changing your URL and crossing your fingers that the website doesn't change it back on you? Well, here too, some plugins can come to the partial rescue. So one of the solutions that's been proposed, and this tool's been around for a while now, is a plugin for Firefox called Force TLS. TLS is one of the encryption protocols involved in SSL. This is a plugin that, when installed, knows about a bunch of websites, some of the most popular, and I think you can add more to the list, and if it detects that Firefox is about to make an HTTP connection to that website, it rewrites it on your side, the request, to use HTTPS instead, so that it doesn't accidentally leak out information. So this is not a bad mechanism. It's essentially a gatekeeper that's constantly watching all of the URLs you're visiting, and if you ever slip up or you click a link that's hard-coded as HTTP, it will automatically change that to HTTPS for you. And that's good so long as the web server actually supports HTTPS and will actually respond to you from that URL. So an alternative to this is one from the Electronic Frontier Foundation called HTTPS Everywhere. Pretty much does the same thing. implemented a little differently, but if you take a look at either of these URLs, or frankly just Google these names, I'm sure they're at the top of Google search results these days, Force TLS and HTTPS everywhere, they essentially do that for you. But it's imperfect, because they only know essentially about finitely many sites, and sure, all it takes is one website to divulge something that you care about, and you could fall victim to your session being hijacked. Now, in fairness, there's maybe not a huge amount of damage you can do logging into one's Twitter account or one's Facebook account, but if in fact you're using a bank that is vulnerable to does not use secure session cookies, and you're in the habit of typing in mybankname.com, which initially is HTTP, even there you should be a little wary. So using something like this isn't necessarily bad if it just adds an additional layer of protection. But probably the best approach, if you must use wireless in some coffee shop or in some airport or hotel or the like, probably the best approach for now, until the world fixes this for us by moving their own websites to HTTPS entirely and to secure session cookies or some other technology altogether, the best, if heavy-handed approach is to use a VPN of some sort. Now, as Harvard affiliates or as extension school students, you have or are eligible for FAS accounts, and FAS itself offers vpn.fas.harvard.edu, which is an SSL-based VPN. It runs on Cisco hardware in this case, and this is a web page you can go to. You'll be prompted to download some free Java application that, so long as you have a Java runtime environment installed, should work, and you'll then have a secure connection between your laptop or desktop and one of Harvard University's servers. But much like the WPA2 solution, this only pushes out your secure boundary by some number of hops. At the end of the day, Harvard's network is still going to connect to Facebook or Twitter or the like using an HTTP connection, most likely, but at least then you're only vulnerable to people with slightly more sophisticated physical access to big, expensive routers in machine rooms, and not just script kiddies who happen to be nearby you on campus or in the coffee shop. But there are some downsides here too. Frankly, one, it's annoying to have to connect to a VPN every time you want to use the internet. Two, if you accidentally get disconnected and don't realize it, you've just leaked your session cookies. Three, a lot of VPNs, including I think FAS's, takes it upon itself to make themselves your default gateway or default router, which means all of your internet traffic then goes through Harvard. So if you're doing something sensitive for work, it's now going to get routed through harvard.edu. If you're trying to print via the network to your local printer, you might not be able to print because your printer is not on Harvard's network, it's on your own local network. So here too, I'm sorry to say I don't have sort of a silver bullet for us tonight, but there are some downsides here too. Now with that said, there are yet other alternatives. You don't have to use FASs, especially if the lifetime of your FAS account might be limited. There are third parties that you can pay, I'm sure, on the internet to sign up for VPN accounts. Probably would be a little wary of just signing up for some random website on the internet, especially if it's cheap. At least do some kind of reputation vetting. But you could also, in theory, run your own VPN. So if you have a decent internet connection at home and your IP address doesn't change, or you know about something like dynamic DNS, which maps a host name every few minutes to your new IP address, just in case Verizon or Comcast changes it, you could, in theory, download I think for the Mac, there's something called iVPN, which is like 20 or 40 bucks, and it's pretty well reputed. I'm sure for Windows, there's something comparable. Or you can buy devices that actually allow you to connect to your own home network or your office computer or whatever using VPN software. If you're particularly comfy at the command line, OpenVPN is free Linux software, actually for other OSs too, that you can download and install too. But for now, if you just want to solve the problem when you're in the most sensitive places, just using some existing VPN, whether your own job or at Harvard. If not the same, then this is probably a good bet. But again, it doesn't solve the problem. It just protects you from the nosy people in your nearby vicinity. Any questions? It's a very real threat now, so stop checking Facebook in any place public unless you use one of these solutions. All right, on that scary note, why don't we take our 5-minute break? All right, so just to give you a sense of how easy it is to sniff other people's traffic, so this is a free tool called Wireshark, formerly called Ethereal. This is sort of the de facto standard in packet sniffing utilities, and what you see for the camera will unfortunately blur all this information so it doesn't get spread. But what every row in this program's output represents a piece of information that's flowing around this building or this nearby vicinity wirelessly. And those of you who have laptops out now, if you're using Harvard's wireless network, work. In theory, thanks for the grimaces on the face, any of the packets here that are operating at TCP or higher level at HTTP or the like, I mean, we could start to get very nosy, double-click on some of these rows and see that instant message you just sent, or see that Facebook update you just posted, or see that email that you just sent. It really is as easy as that. And the fact that so many lines are, this actually isn't even all that much traffic. There's pretty bad wireless in this neighborhood. But there too, one of you seems to be using Dropbox. We can see Dropbox LAN mentioned over there. So that means they actually use encryption. So you're probably fine, but we know that too. If we watch this long enough, ooh, there's a lot of TCP. We can figure out what your IP address is. So in short, tools like this are fairly arcane, but again, the world gets a little scary when people with technical savvy actually run or write software that interprets all of this. And you'll actually see in the commercial market there's a number of enterprise-oriented software and devices whose purpose in life is to interpret all that low-level information and then show the non-technical manager what instant messages were sent today, what websites were visited today. I mean, you wrap a simple easy-to-use, pretty interface on it, and then the world starts to take notice. And again, that's exactly what Firesheep seems to have done for the world today. So just to summarize the Firesheep scariness, one of the best solutions at the end of the day to this is going to be for most of the world's websites to migrate to SSL for everything, or some similar technology. But that's not likely to happen across the board all that soon. And so in the meantime, using a VPN, whether it's Harvard's or someone else's, at least protects you against, again, local nosy people. Using those plugins, one or both of those plugins can't hurt. It will protect you against some sites. But really, frankly, just being mindful of this is probably the best defense. The reality is a lot of us might be perfectly willing to still log into Facebook or Twitter or whatever the website is. This has nothing to do with social networking. Those just tend to be popular. Some of us might make a calculated risk that, all right, I'm sitting in some random restaurant here. Do any of these people really care? Do I care if they see what I'm posting on Twitter? And so you might just go ahead and use the internet. Frankly, that's what you've been doing for 10 years. So really the world has not changed overnight. It's just the world has gotten more educated on this overnight. But it's going to be a while before this is solved for us particularly effectively.
In case anyone's interested, there's something called Black Sheep.
Black Sheep.
Which will tell you if somebody is using Firesheep here.
Interesting. Yeah, someone mentioned this to me today, and I haven't looked at how it works. But at that point, it's probably too late, frankly. For the camera, Black Sheep is apparently a tool that will tell you who in the vicinity, or that someone in the vicinity is using Firesheep on you. And I would think there's got to be a way around that, to be honest. There's technically no reason the plugin should have to show its hand unless it's leaking information somehow. But good to know. Not a bad thing to check. Other questions or concerns? Yeah?
Do you think that Facebook is doing anything to try to detect when this happens? There must be a way that using a super cookie or something.
Good question. Is there anything Facebook is or can be doing here? It's hard, to be honest, because, I mean, really, I would again push back and say, really, the simplest solution here is just to start encrypting a lot of this information and not try to implement various hacks or workarounds. I suspect someone like Facebook will be incentivized to fix this because, I mean, they do have a little security team that deals with sketchy images and identity theft and the like. And I'm sure their workload has been increased. So I'm sure there's a non-negligible cost that's being applied to Facebook and sites like it because people are reporting compromises, because people need more passwords reset. It's probably just creating work and costing time for someone like that site. So I hope something will happen soon. I mean, frankly, again, Google did it with Gmail, which has a huge user base this past summer. And so it's kind of nice that they kind of blazed this path and said, we will do this. You should be able to. And I think this problem will start to go away as people, frankly, just realize we should be turning on SSL. I mean, case in point, even I, as an instructor, have known about this for years. We talked about it in E75 for years, but it was only 2 weeks ago that we ourselves woke up and said, wow, we should really just run the whole course website over SSL, make all of our session cookies secure. So we, too, had our eyes opened, admittedly. So a lot of this boils down to education or lack thereof. Yeah?
If WBP is so insecure, and if that's all I have Verizon Fios router, that's all they offer. If I'm concerned at home, I don't live in a very dense place, but I can see all my neighbors. They all have the same equipment. If I were concerned, what would
what to do. So just to recap, if you've been handed your wireless hardware by Verizon or the like, and it only supports WEP, as seems to be the case with FiOS or DSL in the nearby area, I suspect technologically you can use some hardware other than theirs, or you can just not use their wireless, connect your own wireless router to their device, which presumably is itself a router. And how to do this would probably require reading some documentation or Googling around to get this right, but I would propose one of two approaches. Most likely, Verizon has handed you a wireless router, which means it does NAT, network address translation, so to share one IP address publicly among multiple internal computers. It probably has firewalling capabilities built in and also access point capabilities, to which you're alluding, which means that device is very much self-contained. So one option would be buy an Apple Airport Express or Extreme, or buy some Linksys hardware, plug it into that router. The only gotcha is you run the risk of double NAT, which is generally not good because you can create problems. By double NAT, I mean you're NATing one address, then NATing that address. It's just adding a layer of complexity and potential misconfiguration. But a lot of access points, a lot of these Linksys devices, Apple devices, can be put in access point only mode, whereby they defer to some other device, some other router for DHCP and DNS and all of those services. So really, if you go out and buy your own wireless access point, even if it has more features, so long as it can operate in access point mode, you can just start using different hardware altogether. And you can probably do this for 20, 30, 50 bucks. And the brand names to look at are probably Apple's D-Link and Linksys. Netgear, too, is popular, though I've never been a fan. But those four companies tend to be quite popular. So in short, just don't use their hardware for the wireless aspect. WEP is unfortunately a dated and broken technology. Other questions? All right. So some other attacks that are possible here. So session hijacking attacks, as we just described them, boil down to packet sniffing, really. But there's other approaches too. And just to toss out some of the jargon here, if you have physical access, really all bets are off. So this is really should be a rule of thumb in your mind. You are pretty much SOL if anyone ever gains physical access to some data or some device that you want to protect. All bets are off when it comes to the security of the system if you allow physical access. So just tuck that away. And that could mean having physical access to a computer lab where people have sat down before, stealing your laptop and the like. Physical access, generally bad. With that said, as an aside, getting in the habit as users of computers of using laptops that are fully encrypted. Frankly, Apple makes this wonderfully simple. You just turn on something called File Vault, which does incur a performance penalty, but essentially your whole hard drive is encrypted, and only once you've logged in with your username and password can you access the encrypted data. The upside of this is that if your laptop is stolen, or just lost, then only if that person knows your username and password or guesses it can they actually access your files. They might still have your $3,000 laptop, but they'll at least have to format the hard drive in order to start using it, so your data might be safe. Windows, this is possible, but I don't believe it's built into Windows 7 in any easy fashion, so you generally need third-party software. I think RSA makes some of their own software for this, and many other companies, but frankly, Apple wins this one when it comes to ease of use. Click a control panel, done a few minutes later. Session fixation. This is just a fancy way of saying that an adversary could absolutely just guess your session. If the session keys aren't very long, there's really nothing stopping you from just trying all possible sessions and see if you end up seeing the contents of someone's shopping cart or someone's Facebook profile or the like. Fixing a session is literally as simple as just sending a cookie that is in fact an actual session cookie ID with low probability that you can guess such an ID, but it's certainly very easy to just say your session ID is something that it actually isn't. And then we have attacks like cross-site scripting attack, XSS. So we'll come back to that, though, in just a moment. So what are some of the defenses? Well, we talked about some of the defenses specifically against the packet sniffing scenario and something like Firesheep, but maybe there are some other approaches. What about just having much harder to guess session keys, having bigger, longer session keys? Unfortunately, it doesn't help us at all with something like Firesheep. You can make the thing as long as you want. The guy sitting next to you in the coffee shop can still just copy and paste it using a tool like that. What about rekeying the session? So this isn't a bad idea, and this, to your comments earlier about sort of non-SSL approaches, if the problem is that when I log into a website, I'm given a session ID, and that session ID is then broadcast again and again and again for every web page I visit, you could just tell the browser on each subsequent page request, use this ID instead, use this ID instead. So what you can do in theory is narrow the window of opportunity such that if you rekey the session, at least the session that script kiddie sniffed 5 seconds ago, 1 minute ago, is no longer valid because your session key has been changed and the name of your file in /temp conceptually has been changed. So that's not bad, but this too is just narrowing the window. It's not eliminating it, because if that script kiddie is really clicking fast on the Firesheep tool, there's nothing stopping him from logging into, stealing your session, and now you're logged out because it's been rekeyed and now he or she has the new key. But it is an interesting approach in that at least you can, again, narrow this window of opportunity. Is there an out-of-the-box way to do that? I don't believe so with PHP. I would, at least not with one line of config, I don't think. I wouldn't be surprised if there's various plugins for Apache or PHP that do this. But again, in general, not to say that SSL is perfect, but there's sort of a more robust solution, which is just encrypt all of it and don't worry so much about the implementation details. But again, that too is flawed. And as an aside, what do I mean when I say it's flawed? I mean, there's a number of attacks that are possible with SSL, among them a man-in-the-middle attack, where you accidentally make a secure connection to a bad guy in the middle, who then completes the secure connection to Facebook or the other website. These are hard to ward off other at least with most websites today. But it's that, for now at least, requires more sophistication than downloading some Firefox plugin.
Do sites or Web 2.0 sites that are so heavy with AJAX pose an even greater problem in terms because the user doesn't really know what address you're going to?
Indeed, I think that's a really fair point. So with AJAX-heavy sites these days that are constantly making HTTP requests, if a developer has hard-coded HTTP:// and the cookie, again, has not been flagged as secure in the web server's config file, then absolutely, those behind-the-scenes AJAX calls could be leaking information, even if you, the user, are very careful about always typing HTTPS. Now, with that said, these plugins like ForceTLS and HTTPS Everywhere should catch those requests. But again, they only work for finitely many sites, and even then, only if the server itself supports SSL and doesn't force you back to HTTP. So checking the IP address is an idea we tossed out before, but it's very easily shot down with the idea of NAT, which, again, happens in your home, but also very commonly in the airport, even on campuses or in corporate environments, many, many contexts these days. Thanks to a dwindling supply of IP addresses and thanks to security protocols, whereby you are sharing, you appear to the rest of the world as having the same IP as dozens or even hundreds of other people.
Could you use the MAC address instead of the IP address? Wouldn't those be unique?
So good question, and actually not well-known fact, no, they're not unique. They are often reused by manufacturers, but generally sent in different shipments. Supposedly, so that with low probability will you buy 2 cards with the same MAC address, but it's a lot easier to just start reusing them if you assume that they're both going to be shipped to East Coast and West Coast. Even then, if you used MAC addresses, though, at the end of the day, if you're still sending it to the web server via the HTTP protocol, and thus in the header, you can send all the special information you want. It's still going to be sniffable. So again, if it's in the clear, you're at risk. Yeah? Good question. What if along with the IP address you check the source TCP port? Clever, and it's not bad. It's going to require that someone like Eric Butler go back and redo his tool. Unfortunately, TCP port numbers are contained in the clear in any TCP packet that goes across the wire or the wireless network, and so even that too could be sniffed, and then my own laptop, if I'm the one running Firesheep, could just use that same source port. Assume.
Provides a unique way of identifying the user.
Yes.
Because the traffic has to get back to that user, so there has to be something unique on the way.
So that is true. I see. So let me think about this for 1 second. So yes. So as an aside, the way NAT generally works these days is, of course, 2 people in your same home or internet cafe can visit like the same website, facebook.com, And we'll have different private IPs, but to the rest of the world, we have the same public IP. And yet somehow I get my profile and the person next to me gets their profile by default. This NAT does in fact work. Even if both of our computers happen to have chosen the same source port. So even though most of us are probably familiar with the idea of destination ports, 80 for web, 25 for mail, 22 for SSH, turns out there's another port involved in any internet socket connection, namely a source port, and it's generally a pseudo-random number greater than 1024 that your laptop or desktop computer chooses. So even if by chance I and the person next to me's computers choose the same source port, the way NatWorks does is it will choose its own source port and then remember which of its choice of source ports maps to which of our private computers. So in theory, you could enhance this protocol called HTTP by associating the source port with it, which would then help ensure that even if some person in my proximity forged my session cookie and requested the same content, he could not forge the same source port because that would be handled at the router. Not a bad idea. Unfortunately, now it requires hardware support or firmware support, and also it commingles the idea of layer 3, which is where TCP is described as operating, and layer 5, which is HTTP, which means now you have this commingling of protocols, which is generally not supposed to happen. It's doable, but very quickly would get hackish. And again, I would just say, just turn on SSL. But not bad. That's actually that's a good thought exercise. Good exam question if we had an exam, to be honest. All right, so what about this SSL? So we have talked about this a couple of times thus far, so we won't dwell so much on the implementation details of SSL itself, but we will at least talk briefly about the cryptography underlying it and why this actually can help things out. So recall that to actually get yourself up and running on SSL, you do need something called an SSL certificate. Well, first, you need a public and a private key, and you can generally generate these public and private keys yourself by running a command at some prompt. In the command line environment, it's usually a program called OpenSSL, free software. You run it with some switches. It's an annoyingly arcane interface, frankly. I always have to Google how to use it, but thankfully many people have documented it ad nauseum. You run a command. You get two files as a result, a .key file and a key file and a .cert file, or .csr file. I'm trying to remember all the mechanics of it. That is a certificate signing request, one of those files. You then upload this to someone like GoDaddy or VeriSign or Network Solutions, whoever you're buying the SSL certificate for, and they essentially rubber stamp that certificate and give you back a different text file that includes not only your public key, but also their digital signature. And the way SSL works thereafter is once you've added that certificate to your web server's configuration, and this is the sort of thing you read the documentation for or Google around for, when someone requests your website via HTTPS, both their browser and your web server present to them, here is my public key. And as I think we've discussed in the past, that public key can then be used to encrypt a message to you, and you can use their public key to encrypt a message to them. And long story short, now you can start communicating securely thanks to the mathematics involved. The digital signature is useful because browsers have this so-called chain of trust, whereby Microsoft and Mozilla and Apple and Google have a number of SSL providers, essentially, that they trust. They deem these are legitimate companies. They actually have tax ID numbers and all of that. So we are going to configure our browsers to trust any secure connection to any website that's had its public key signed digitally, so to speak, by one of the people we trust. And it's a chain of trust in that if Google trusts them and they trust me, then everybody's kind of happy, even though there's way too many people in the story to actually have this be a compelling story on the internet at large. But at the end of the day, what does this mean? If you've probably seen, even I goofed and I let our SSL certificate expire for a few hours or a day or so earlier in the semester, and some of you then had to jump through hoops. In one of our websites, you had to jump through hoops to actually see the course's website, because Firefox, for instance, says this certificate is expired. Do you want to confirm? And you have to click up here, then down here, then up here. I mean, it's ridiculous. For a non-technical person, there's no way in hell they're going to actually reach your website that day. And even I get annoyed anytime this happens. So the browser vendors have raised the bar, at least, to really incentivize people to get into the habit of building this chain of trust. for better or for worse. Unfortunately, doing so requires money because you have to pay any one of these known people to actually certify your certificate. And the reality is, if you look through your browser's configuration, there are so many certificate authorities these days that it's kind of a little discomforting anyway as to how many people are involved in this process. Anyhow, the value of this is that once you've enabled SSL, all of this stuff, which clearly has been the source of all of our problems thus far tonight, gets encrypted. And so now at least, yes, it can be forged, but no one can actually see what this big random cookie number is. And so you're much safer because the cookies are encrypted along with all of the other HTTP headers. But there's a gotcha, at least with shared web hosting. Recall that this one doesn't have it here because this is a response, but in an HTTP request, there's one header that's very important in a shared web hosting environment. What was that one? The host :HTTP header, because the browser has to remind the server, this user typed in foo.com or bar.com or baz.com, because if all of those domain names map to the same IP, the web server has to be able to multiplex and figure out which index.html file should I serve up, foos or bars or bazes. Unfortunately, because the world didn't really think this through, if you're encrypting all of this information, and among that information is host : you don't know what private key on the server to use to decrypt incoming requests unless you try all possible keys, and that's just not an ideal solution for a shared environment where you could have hundreds of websites all operating on the same. So in general, as I think we said a few weeks ago, for SSL, you generally need a unique IP address per website, which means you, the end user or the customer, have to pay for this usually. There is an exception to this if you want to run multiple subdomains in the same domain. You can get away with one IP address for all of them, so long as you use one certificate for all of them. So it turns out if you're willing to pay a bit more, you can buy what's called a wildcard SSL certificate, whereby VeriSign or the like will essentially approve star.cs75.net, and you can then use that certificate for all of your subdomains. So that's at least a good thing. For companies or sites with a lot of subdomains, you don't have to pay through the nose for every subdomain, but you do have to pay more. For the course, for this course, in fact, where we have lots of subdomains, it's $199 per year for the SSL certificate, but that's better than paying $49.99 for every single subdomain. So what's another threat here? While I have this up, I mentioned that a couple of these are potentially worrisome, and I think this too has been proposed during Q&A in the past. This is a little too much information. Some of this is useful technically, content length, content encoding. This is useful for figuring out how to interpret the message. Why do I have some concern with ext powered by, despite the silliness of its name, and the server headers? What's potentially risky about those two headers being in this response? Yeah?
If there's any known vulnerabilities in PHP 5.3.3, you're essentially telling everybody, come and get it.
Exactly. If there are any vulnerabilities in PHP 5.3.3, why the heck are you telling the whole world what version of the software you're using? I mean, there is very little to no value in your broadcasting to the world, unless, frankly, the folks at php.net or the folks at Apache just want people to be able to gather statistics on what software is being run on various websites, because if this is being sent in the clear, you can actually do decent analytics of all of the websites out there by just looking at these headers. But for you, the security-conscious developer or sysadmin, there's really no value to this. And so you should generally turn these headers off by searching through the config file and looking for the appropriate line to disable this. I've left it enabled here, but certainly powered by is pretty useless. And Apache, that too, pretty useless for most application purposes. So back to SSL. So how does SSL work? It's generally an example of public key crypto, which we won't spend really much time on the mathematics of, but again involves big random numbers generally involved in the process, and a public key and a private key. RSA is generally one that's used in common practice today, but one that's a little easier to understand, at least quickly, is a variant of public key cryptography called Diffie-Hellman, or DLP. So this picture here essentially tells the following story. Alice and Bob want to establish a shared, secure connection, but they've never met before, and so they need to do this without having whispered into each other's ears some secret that they can use. So there's a motivation here for public key crypto because Alice and Bob have never met. Alice is on the left, Bob is on the right. And this is going to use something called modular arithmetic. The mathematics can get hard and interesting, but we can actually just wave our hands at some of it because the basic examples are pretty straightforward. So how can Alice and Bob possibly start communicating securely? Well, in general, to communicate securely, you do have to have some secret shared between the two of you and only the two of you. But obviously, if they've never met, they can't agree upon this in advance. So how in a noisy room can you both simultaneously come up with the same number? Turns out there's some useful mathematical tricks, and one of them is, again, through this kind of thing called modular arithmetic. So suppose that Alice chooses a random number, call it A, and Bob chooses a random number, call it B. These are usually pretty big numbers. In advance, and this is totally fine to just broadcast this to the whole world, this is not private, they need to agree on a number G, generally called a generator, and a number P, which is a prime number in this case. It is okay if the whole world knows what G and what P they're using. What the whole world should not be told is what A or B are yet in the story. So what do they then do? So Alice does some mathematics. She takes this number G, which is very often, frankly, the number 2, doesn't have to be big itself, 2 to the A, where A is big, 2 to the anything big is going to be huge. So mod takes the remainder, P, and P is generally big too, but not as big as the exponentiation. So long story short, Alice, using her calculator or computer, computes G to the A, remainder P, and now sends that number across the internet. Can be completely insecure. Anyone can intercept that packet, but the point is she does not send A, she sends the result of the mathematical operation, G to the A mod P. Okay, person B does the same thing, but he uses B instead of A. So at this point in the story, both Alice and Bob have two numbers, G to the A mod P, whatever that is, and G to the B mod P, whatever that is. But they both have it, as does everyone else on the internet. But what does Alice not have, just to be clear? B. And what does Bob not have? A. Okay. Right, A. So what happens next? So this is really the last step. Alice takes the number she's received from Bob, which we're now describing generally as T sub B, right? And it's just a little substitution here, so we have something else to call it, T sub B. If you raise the number that she received to her own power A, and then take the modulo of it again as needed, that is the same as doing the same thing on Bob's side. So in short, G to the A times B mod P is the same thing mathematically as G to the B times A mod P. So what's neat, at this point in the story, thanks to relatively simple, conceptually, exponentiation and then modulo operations, now both Alice and Bob have the value G to the A times B mod P, whatever that is. But that number has not been transmitted across the internet. The only thing that was transmitted across the internet was this, which is part of it, and this, which is part of it, but because they've kept close to them the so-called private key, they can now compute this total number. So what's really neat about Diffie-Hellman is that even in a noisy room where everyone can hear what you're doing, so long as you keep just one number close to the chest, A for Alice, B for Bob, you can nonetheless agree in very much public circumstances on some shared secret. And now Alice and Bob can go ahead and use DES, triple DES, AES, any of these so-called symmetric key ciphers that just requires that you have a secret key. Frankly, they can use a Caesar cipher, ROT13, ROT12, ROT10, if the number they've come up with is 13 or 12 or 10. So it's kind of a neat way of establishing a shared secret. RSA works differently, but the end result is essentially the same, a shared secret between two parties. So why is this relevant? Well, even though this is not really the one used in SSL, this speaks to the one implementation approach of someone like me establishing a secure connection to Amazon.com, who is run by people I've never met, and yet somehow we can still establish a shared secret. This is just one approach. And there's many variants of this particular implementation. Any questions on SSL? SSL is a good thing, so long as you turn it on and turn it on correctly, even though it does have, it's not perfect. All right, so what about all these doofuses who are getting slash-dotted by attacks that have also been around for many years, right? This is also not something new. This is also not all that hard to even protect against. You just have to be in the habit of actually protecting against it. So here's a sample login that we've used before for our discussion of logins. Notice that it has a password field, a username field, and a login button. And now suppose that the SQL query that I use in order to verify someone's username and password is something like this down below. There's many ways, as you've realized from Project 2, that you can implement code like this. In this case, I'm using sprintf, just so that I can have some placeholders, %s, but I could use concatenation in PHP, the dot operator, or anything, like that. But the point really for today is not the PHP details, but the SQL details. So what am I doing here? I am constructing a string that says select UID, for user ID, from users, where username equals this quoted string, and password equals this quoted string, and I'm passing in the values of username and password. So if you're not already in the habit of grimacing anytime you see code like this, you really should. Never, ever, ever trust user input. Even if you think this is only going to be used by people I trust, don't trust them anyway. It's too easy to just add the defensive code. There's no telling, who might inherit your code later, and then it comes back to bite you. So why is this dangerous? Well, suppose that I actually trick the server into executing this code. So it's red because it's bad. Why is this bad? What will this query return? And actually not not all users. Oh, actually, password. Yeah, so what will we get back here? We will definitely get back at least one user ID because of the OR, which is saying OR 1 equals 1, which is kind of a uninteresting statement, but unfortunately, it's a statement that is always true. Now, I could have said 2 equals 2, 3 equals 3, A equals A, whatever. The point is that it's always a truth value, true. So why is this bad? Well, one, it's always going to return a user ID. And if this is being used in the context of an authentication page, feels like it's going to let the user log in as one user ID. Who knows which? Maybe Jay Harvard's, and maybe if he doesn't exist, someone else's. So this doesn't seem all this bad. So long as I'm not an idiot and don't write this query in my PHP code, well, there's no danger. Well, there is if you're dynamically constructing your SQL query, as we did in this example here. So notice the potential danger. Right now I have select UID from users where username equals this and password equals this. But notice I'm using single quotes, which is good. Single quotes inside of double quotes is okay. But what if the user types a single quote? Feels like they could presumptuously close my single quotes, then proceed to do whatever they want, then reopen my double quote, and still have a syntactically valid expression. Let's see how relatively easy this is. So this is the danger, but again, I'm not going to write this. But what if the adversary can trick me into constructing this string on the fly? Well, what if the user does this? So I'm going to zoom in here. So username is Jay Harvard. And what if they type a password of, and I've removed the bullets so we could actually see what they're typing, 1, 2, 3, 4, 5, single quote. So that completes my first single quote. Space or space, quote unquote, 1 equals quote 1 without the single quote, because I'm now assuming that I'm the doofus who left another single quote in there, which will complete this adversary's SQL expression. So in short, it's an incomplete SQL statement, but it's trying to exploit the high probability that someone like me at least got into the good habit of quoting my string so that my SQL queries don't break. But unfortunately, if I'm not scrubbing their input and I'm just letting them type in apostrophes, they could trick me into constructing a query on the fly that I did not intend. And so what happens? Well, what happens then is, of course, that we execute this bad query here, which will absolutely return a user ID. And if, again, that's all it takes to log into the website, bam, they are logged in. So I don't know offhand what the exact query is that the Royal Navy's website was compromised with, but it generally reduces to something like this. And it's not all that hard to find vulnerable sites, to be honest. And this is actually a good, an amusing habit, at least for a programmer or a computer scientist. Next time you visit some website that has a form, just type something like an apostrophe into the field, or type the name O'Malley, or anything with an apostrophe, anything with double quotes just to mess around with it. And if you get a weird error message or the server fails, there's a candidate for a SQL injection attack. And I myself just kind of randomly have tried doing this on various websites. You'd be shocked, frankly, at how often the site errors, not just saying, sorry, invalid characters, but like you see a dump from the server itself saying invalid expression or something like that that you really should not be seeing as the end user. There you have it. That's all how these people find these SQL injection attacks. They visit all these popular websites, type apostrophes or semicolons or weird characters into websites. The moment the thing fails ungracefully, there you go. Now you got to just figure out what query to construct, and it's almost always involving things like quotes and the like. So here, too, is the sort of disappointing lesson. It is really this easy to ward this off. And as I've said, this is a ridiculous name for a function in any language, way too long. So it's a little annoying to type, but that should not be your excuse when like your site gets compromised. Oh, it's such an annoying function name to type. Alias it if you want somehow. It really does boil down to, at least in PHP, code that's as simple as this. And what does this actually do for us? Well, as the name implies, it does escape the string so that in this case, what would happen, green is good, it would put backslashes. Literally, as simple as that. Backslashes in front of the single quotes so that if they're there, now at least it's as though the user's password actually has apostrophes in it. They won't accidentally be interpreted as part of a SQL query. You can still type O'Malley or the like. Your name can still be like Mr. O'Malley, but because the server, or the SQL server, will not think that your name has to now be quote Malley. This is really just for the query purposes. And it is this easy. Yes?
While looking at documentation, I happened upon that there's another function called MySQL escape sequence. It's like an older deprecated one.
Okay.
Real escape. And they said, real escape is the one to use now because it also includes like other character sets, or it handles other character sets, exchanges also.
So agreed, yes. So the one to use is the real one now. And thankfully, and realize too, if you've not played or taken it upon yourself to play with other APIs, you're welcome to for the final project. The MySQL API that we use in PHP that has functions named like this, it's actually fairly limited. It's not object-oriented, which means it's a little harder to encapsulate things nicely. So realize, especially for your final project, or even for your final project, that there's the MySQL Intermediate API that's built into PHP that's a little more versatile, and frankly, it helps you deal with things like this. You can do what's called prepare a statement using that API, which is very common in many different languages, Java in particular, with anything involving ODBC and the like, where you can create strings where all this escaping happens for you. You generally put a question mark, not %s, where you want some string, and then the API deals with the escaping for you. So realize that even though, again, we've been kind of taking the lowest common denominator approach to build our way up, thankfully there are libraries that make your life a little easier, but you have to use them, and clearly not everyone on the internet, even with well-known sites, actually does. All right, so let's transition just a little bit now to the world of JavaScript, and the motivation here is to actually start looking at some of the issues involved in security with AJAX and the like, also with an eye toward Project 3. So a teaser for Project 3 is this. For Project 3, you'll be implementing a mashup, which is jargon for taking this and mashing them together and making something more interesting. And the two things in this story are going to be the Google Maps API and an API from San Francisco BART system. So San Francisco really has a nice set of data, real-time data, that they make available to the whole world so that people can make iPhone apps and Android apps and websites and the like. And by that I mean they provide you with the locations of all of their stops in terms of their GPS coordinates. They provide you with the numbers and the times and the schedules for all of their buses and all of their subway cars and the like. The MBTA, as an aside, does provide a lot of this same data, but they limit the number of requests you can make in a day, which is not good for a large class, many of whose students would be all testing this simultaneously the night before something is due. So they very foolishly made the design decision to limit people's connectivity. But we contacted the BART to make sure this is not an issue. Great people there. It frankly seems to be sort of a volunteer basis over there where they thought this, a few people there think this is a great idea, and they've really loved that so many people have taken advantage of this. So we're quite grateful for them making available such a rich data set because it allows us to use an API like Google Maps. So Google Maps is a wonderful API for a couple of reasons. One, It's really well designed from a JavaScript perspective. It's really a nice opportunity to learn some fancy features of JavaScript beyond like the form validation and that sort of stuff we did a couple of weeks ago. It really now is taking JavaScript for a spin far beyond its capabilities just a few years ago. And its documentation and examples are really quite rich, which much like PHP for us from the courses perspective, it's a great learning tool because there's such a rich amount of material available with which you can learn how to do various things. So for instance, if you want to make your own Google map, if you want to embed your own Google map in a web page, it really is as simple as this. You write your HTML or XHTML. You would then have a div element that you give it a unique ID to, like map canvas. Maybe you stylize it here in a CSS file with a width and a height, and then you call one JavaScript function somewhere. And that JavaScript function grabs that div, fills it with a map at whatever dimensions you specify, and then you can click and drag and interact with that map just like you can the real Google Maps. You can do some really cool stuff. We have demographic information on some of our students in another course I teach where they gave us the names, not full addresses, but the names of their hometowns. And so you'll see here a map with about, actually, let's do this one instead. If we go to cs75.tv, our own open courseware site, there's a form that folks on the internet can, by choice, fill out to say where in the world they are. And so what you see here in just a moment, I forgot that I'm on a slow wireless connection. I should have changed to the wired connection, but I wanted to sniff some traffic. Come on. Come on. Let me switch in a moment to a wire. Otherwise, it will not be very fun to play with the API. Disable. Give me one moment. Okay, that felt much faster. Come on. Here we go. Okay. So every one of those markers represents someone on the internet who's turned into CS75s or CS50s videos and has told us their name and where they actually live. And it was relatively easy to do this. So this is a mashup of, in this case, Google spreadsheets. I used a Google form with which to solicit people's information. A Google spreadsheet can be exported automatically in CSV format, much like Yahoo Finance. So every hour, I think, I have a cron job, a script, PHP script that runs, grabs the latest CSV file, and then when you request the information, when you request this mashup, it then drops a marker where every one of those people actually is. And what we can do, just like any Google map, is click and drag over this way. We can see that out here in Mexico lives Manuel. Over here is Buster. Over here off the coast is Angelina. We can zoom in on this. And it's really quite cool and really quite easy how it was to do this. I just have a div in my page. I then told the Google API, populate this div with a map, and then I had to write the JavaScript code that in a for loop or a while loop iterates over my CSV file and then drops a marker using another function from the Google Maps API and drops it in that particular place. And so what you'll do for this project is something very similar in spirit, whereby the BART, depicted here, and the URL is in the PDF, which is already online, has a number of different formats for their data. They have a data format whereby you can get back data in JSON format, JavaScript object notation, which is just a nice succinct representation of data that you can load into memory. They have an XML format if you'd rather sort of revisit some of your Project 1 skills, and that XML feed contains the times at which the next several buses, for instance, will arrive at a stop. And they also provide you with data on the geographic coordinates of all of the stops and the lines, because what you can also do relatively easily with the Maps API is draw lines on a map and actually trace paths much like you could the route for a bus or a train. So if I go to, let's see, overlays, and I go to polylines, as they are called, you'll see this simple example here, which for some arbitrary reason has traced a line on a Google map from Australia to California. And it looks like this is probably 1 or 3 function calls to go from there to there to there and to there. So it's great fun, to be honest, this particular project, because you get to play with some real-world data. This is not some pizzeria, frankly, that's gone out of business. I mean, this is real-time data that's going to change every minute of the day while you're playing with it, and the Google Maps API is really representative of a rich resource out there. You'll find, too, that for this project, more so than the past, it's left to you to explore and play with the API and its documentation to figure out how to use it, but I think you'll find that there are ample resources on Google's own website for figuring out a lot of the puzzle pieces, but you'll see in the spec that we prescribe exactly what your map needs to do. Essentially, you need to create an application that has an embedded map with a list of all of the various routes or stops, so that when you select one, you immediately see an overlay for the various routes. So if you think in the context of Boston, if you selected something, you'd see the tracing of the red line or tracing of the blue line, but you'd see the San Francisco equivalent, and then you should be able to click on any one of the stops on that line and see when the next several buses or trains are arriving at that location. And thanks to AJAX, thanks to JavaScript, and thanks to the XML or whatever feed you choose to use, it's all going to be real-world, real-time data. So it's quite fun to use. All right, so what's the connection now to security? Well, there's actually some gotchas when it comes to using JavaScript in a mashup environment, which frankly is very much in vogue these days. In fact, for Project 2, with CS75 Finance, of course, you made a connection from PHP to Yahoo Finance to get the CSV file, and then you use the return value, the CSV results, to actually render some portfolio value or some stock prices. Well, you might think that, wow, that's pretty cool. Why, though, even bother involving the server? I could rewrite CS75 Finance in mostly JavaScript and have a very sexy, dynamic, interactive interface that when I click some icon, it doesn't go back to the cloud.cs75.net and then reload the whole page. I could use the AJAX tricks that we looked at over the past couple of weeks, but you can't. So there is this same origin policy in the context of browsers that essentially says if you are visiting a page whose URL is foo.com, you may not make AJAX requests to bar.com, another domain, and then integrate the response into foo.com's content. You would be violating the same origin policy. So the same origin policy is a set of restrictions that all of the major browsers adhere to that, again, essentially say if this content came from foo.com, you can't go grab content from bar.com and do anything useful with it. Now, there's some slight exceptions to that. There's a technique called JSON-P for JSON padded, whereby you can work around this, but the website needs to support that technique, and Yahoo Finance does not. CSV is obviously not JSON-P, and unfortunately not that many websites actually support that. Though as an aside for your final projects, you'll recall perhaps that I've alluded to various APIs, campus-oriented APIs that we make available through this other course of mine for events on campus, news on campus, maps on campus, and the like. All of those APIs, I believe, support JSON-P, so you can actually implement this, but we are very much in the minority when it comes to this feature. Facebook, I believe, supports it as well. So what's the implication here? So this so-called policy affects pretty much any interesting aspects of web pages today. If you've got frames, you can't get around this. If you want to use AJAX with XML HTTP request, you can't get around this. If you've got cookies from one domain, another cookie the other domain can't access it. In short, same origin policy is generally a good thing because it means that if you visit some popular website like CNN.com and they have advertisements, the advertisers can't just see what your CNN cookie is. They can't see what you're looking at on this page. They don't have the right to look at any domain content other than their own. So in general, this is a good thing. But as developers get more sophisticated and start to leverage increasingly dynamic technologies like AJAX, it does start to create hurdles whereby you have to jump through a bit more hoops. So you may very well trip over that either for Project 3, but more likely your final project if you start dabbling in things AJAX. So tuck away that trying to ever access content in JavaScript from another domain other than your own generally will raise some kind of red message in Firebug or the like saying access denied. So there's a couple of more attacks now that are actually surprisingly easy and probably not something you even thought about. Even in the context of Project 2, you might have unknowingly made this mistake. Unfortunately, the world likes acronyms, and I myself rarely remember what these stand for, but cross-site request forgery, otherwise known as CSRF, because that's easier to remember, and cross-site scripting attack, XSS. You actually hear about the second of these quite often in the press. So what are these threats, and how do they relate to the type of stuff we've been doing? So here is a cross-site request forgery attack. And I've described it in 4 steps. Suppose you log into project2.domain.tld, so your website. You then visit some bad guy's site because you click some link or you go to some sketchy website, so you end up accessing his site for some reason. But that bad guy has a hyperlink to project2.domain.tld/buy.php symbol equals this thing, which is a penny stock. So there's nothing stopping this bad guy from just putting any links he wants in his web page. But what he seems to be doing is he seems to have poked around your website and realized this doofus used get for his or her buy requests. Now this is problematic because if you've logged into your CS75 finance site and yet you then visit another website, you're still logged into our site, you then visit this other website and you unknowingly click a link that just so happens not to lead to some other page on that website, happens to lead back to your own version of CS75 Finance, and you've, again, implemented buys using get, what happens when you click that link, as step 4 reveals? You've just been tricked into buying a stock because you're already logged into that website, which means you won't have to be authenticated again because your session cookie is still valid, and it's not hard to forge a request when the request is a get request. So cross-site request forgery, now it kind of makes sense. Cross-site is in that the link came from somewhere else. You clicked it in an email, you clicked it in some bad guy's website. Request forgery, I mean, that's frankly a little generous. This is a request. It's forged in as much as he's mimicking your own choice of URLs, but in the end result is a bad situation there. You've now been tricked into buying. So how do you mitigate this? What could you do? You realize, damn, I thought it was really clever of me to support buys because now I can have user-friendly links on my website that says, if you want to buy this share, click here, click here. A lot of you probably did this. So what's the solution then? It's probably not acceptable to tell your user, don't visit any other websites while using ours. So what could you do? You could make a confirm page. And in the real world, this is probably the de facto standard, right? If you want to buy something in E-Trade, there really isn't Amazon calls it one-click. So there's probably not like one-click thousands of dollars transaction on most of these brokerage websites. You probably do have a confirmation page. So you at least have some barrier that requires human intervention that can't be simulated by some bad guy's hyperlink. You actually need human interaction. You could, of course, what's the obvious solution? Just use post, right? If get is tricky because it's so easy for someone else to simulate it, at least you can raise the bar somewhat by using post. But wait a minute, if you use post, what can the other guy do?
Look at your traffic and spoof the post.
Yeah, and spoof the post. How could he do that? Well, there's nothing stopping him from not making a hyperlink, but making an HTML form whose action attribute is your URL. Right? So now I have to be a bit of a doofus and now submit this form or click this button. But again, it's not that hard to do. And with JavaScript, you can make a link submit a form or an image submit a form. So there's many different ways that you can trick someone even into submitting a post request. And you can make post requests via AJAX as well. So there are ways of creating this problem in any number of ways. In fact, here's the scary thing that you probably never thought about. You don't even need to have the user click on anything. Suppose you instead did this. So these are a little small, so let me zoom in. Suppose that you, the bad guy, you're just kind of hoping that someone on the internet logs into CS75 Finance and then visits your website. The threat we just described involves me, the human, clicking on something. I don't even have to click on something. Suppose the bad guy just has an image tag whose URL is buy.php equals stock symbol. Now it's as though I've automatically bought this stock. I didn't even have to click on anything. The second one here is, what about a script tag? The script tag will, of course, load its URL. What if its URL is buy.php? You can kind of see where this is going. Any HTML tag that supports some kind of source attribute that will just automatically be loaded by nature of HTML, like an iframe, another script tag. In fact, this one's a little tricky to detect. You can just have raw JavaScript code, because you can scrub these pretty easily, or rather, no, ignore that. You can even have raw JavaScript code like this, which also induces a call. So there are so many ways in which you can be tricked into doing anything with a single click. So realize, too, that even any website that allows you to do single click anything, generally a bad thing. At least Amazon, for instance, is in this habit. Slightly annoying that even if you're logged into your account and just viewed your own shopping cart before you buy something, they almost always require that you authenticate again. Now, all that does, though, frankly, is it narrows the window of opportunity. There's nothing saying saying that odds are you could still pass that confirmation screen, not quite check out yet, and then visit a bad guy's website, bam, you've just checked out thanks to that URL or whatnot. But again, at least it raises the bar, and that's really a theme of security, and even of tonight, is just raising and raising the bar. We never quite make things perfectly secure, but we at least make it harder for the bad guys to get at us. Well, what are the actual defenses against this? So post was one. HTTP refer is actually a common suggestion. Why not just check where the hyperlink came from? Unfortunately, not all browsers send the HTTP refer, especially if the user's installed some privacy guards. There's no requirement. So relying on HTTP refer, as an aside, is rarely a good thing because it's not something that's guaranteed to be sent. Append session tokens to URLs. So this refers to the idea of including some unique string that the bad guy is not going to be able to predict. So this is something you could implement on your side to at least make this a bit more challenging. We talked briefly about this before, expiring sessions quickly as by rekeying them constantly, just to, again, narrow the window but not eliminate it. CAPTCHAs, same idea to Amazon's confirmation screen. Just have the user solve a problem that a piece of JavaScript code cannot as easily, and as Amazon does here, prompting to relog in. But this is the one that's very much in vogue or gets commented about a lot. So this one takes a little more sophistication to follow, and unfortunately a smaller font, but let me show you this link. It too can be a 4-step threat. So suppose that you click a link like this. You're visiting a website, vulnerable.com. So I've called it vulnerable.com because the implication here is that whoever programmed this website didn't really know about XSS attacks and accidentally did not escape user input. So again, neophyte mistake. Always escape user input from forms. Always escape input that's going into a SQL query, but always also escape input that might get echoed back to the user. Whenever you pre-populate a form field, you don't want to call MySQL real escape string on that, but you do want to call HTML special chars on that in case the user enters like an angled bracket or an ampersand or anything potentially scary. So vulnerable.com was not well designed. Suppose that someone clicks this link, vulnerable.com, foo equals, and then passes a value there that actually happens to be some JavaScript code. That JavaScript code changes the browser's address to badguy.com, log.php, cookie equals the concatenation of document.cookie. So what's the implication here? I argue that if vulnerable.com is designed to take this user input, the variable foo, and maybe think of foo as username, something a user might actually type into a form, but suppose that the user doesn't type suppose the user is tricked into clicking a link that leads to a GET request that populates the form field foo with a snippet of JavaScript code. Now suppose the vulnerable.com website actually echoes the user's output. Maybe it realizes this is not a well-formatted username or whatever. I'm going to just tell the user as much by pre-populating the form field. Now the website is accidentally embedded in its own HTML source code what? JavaScript, a script tag, which is JavaScript code. But because the web server was tricked into doing that, the origin of that JavaScript is vulnerable.com, even though it originally came from a URL, because the web server spit it out. So now we've circumvented the same origin policy protections. If this JavaScript code appears now to have come from the web server, because it just blindly echoed what the user accidentally passed in as a GET request, now document.cookie is accessible to this JavaScript code, and so this snippet of JavaScript here that sends the user accidentally to badguy.com/log.php, it's a bit of a contrived example, but it does illustrate the power here, is essentially going to send to badguy.com all of my cookies for this particular website, among which might be my session cookie. So here's an even more sophisticated way of stealing someone's session even without any wireless proximity or fire sheep tricks. This can be anyone on the internet. If I can trick someone into clicking a link that actually contains some JavaScript code that's accidentally going to get pasted into a web page's source code because the programmer did not call HTML special chars, therefore changing angled brackets to literally angled brackets as opposed to HTML tags. And the thing is, you might think that, all right, only an idiot's going to see badguy.com and still click that link. It is very easy to encode these things, right? No normal person or non-technical friends of mine are going to really notice what %3a, %2f. Right? It's very easy to obfuscate this in a way that still will induce a problem, but that isn't so obvious to the end user. So in the end, badguy.com gets all of our cookies, and as we've discussed earlier, that means they can now log in to that website or do whatever it is that you've been doing on that same website. So what to do? Well, hopefully you're already in the habit with all the phishing attacks that have gone over the years. Rarely should you ever click a URL that you've been handed in an email, especially if it's to anything sensitive like a bank account, PayPal, even something like a Facebook account. In fact, I'm surprised. Facebook, if you use it, is among the sites that sends automated emails very often with links with which you can confirm friends and log in and all of this. I'm surprised I don't get more phishing attacks for even Facebook accounts because they're getting their users, many of whom are non-technical younger people, into the habit of clicking links that could very well go to badguy.com unless you're checking the source code there. But the end, don't trust the user, encode all user input, and if you take, again, nothing else away from tonight, that lesson and the one to stop using wireless. So we will see you next week. Project 3 is on the website.